Hello, everyone. Thank you for joining us today for our event on how to deep dive into your logs using SQL. My name is Lauren, and I'm the content manager for the Google Cloud community. And joining us today are Afrina and Sumit, who will be taking you through the content and answering your questions. Questions are encouraged, so please feel free to add those into the YouTube chat box, and we'll be sure to get to them either in the chat or at the end of the presentation. We also have a few pre-submitted questions that we will cover as well. For any questions that we don't get to, please drop them into the Google Cloud community, and someone from the community or the Google Cloud team will be able to help you out. And there's a link to the community in the YouTube description. All right, with that, I will hand it over to the team to take us through the content today.
Awesome. Thank you so much, Lauren. Good morning, good afternoon, good evening, everyone. I hope you are having a terrific day so far. My name is Afrina, and I'm a product manager working in Google Cloud. I work in the observability space, particularly on Google Cloud operations. I have over a decade of experience working in cloud and SaaS-related products.
Hi, everyone. My name is Sumit. I am engineering lead building the logging products. Most recently, very excited to build and launch the log analytics product, and very happy to be here to talk about log analytics.
So if you have not guessed already, our work life is 90% logs. So that's exactly what we do day in and day out. So without any further ado, let's get started. Awesome. I need a quick minute to fix my slide. One moment. Second. Apologies, running into a quick technical issue. Awesome. So here's a quick glimpse of what we're going to talk about in the next 35-ish minutes or so. We'll start off with an overview of cloud operations, talk about what are the different types of logs, and then drill into why did we pick SQL and why we think it's one of the most powerful tools for you to analyze your log data. And then we'll talk about how to make your troubleshooting journey easier. And Sumit will talk to you about different use cases and at what point, how can you run your queries efficiently. And we'll also show you a demo towards the end. Awesome. So without any further ado, let's get started. So Google Cloud Operations is a suite of observability products. There are three big products within the suite, which is cloud monitoring, cloud logging, and trace. Essentially the three pillars of observability. Cloud Operations offers a high degree of interoperability, meaning you're able to go between logs to metrics, metrics to logs that preserves context during a troubleshooting or a monitoring scenario. So Cloud Ops caters to four main important type of users, right? Number one is developers. Like you want to resolve a code issue on your local laptop or you're solving a production level issue. Number two is platform admins or platform engineering teams. You're typically responsible for managing the platform centrally for your company. Number three is business analysts, right? You are people looking to make business decisions, and you could always use your log data instead of using the same data in another tool, right? So use cases would be like you want to know how many searches occurred on a page, or how many people search for a particular product, or where are your users coming from? Just all business-driven decisions. And finally, security analysts, right? People who care about generating SecOps reports. And they're responsible for compliance, audit, and all of that. Great. Let's talk about scale. We handle roughly 2.5 exabyte of log volume on our logging platform. Someone told me that's probably all the words that humans have ever spoken. Don't quote me on it. I do not know, but it could be, right? 2.5 exabyte is large. So when scale increases, there is a huge need to develop tools that can help you analyze logs at scale. Meaning, a lot of times you might have a consumption that, okay, my performance is going to break at scale. And I want to say here at Cloud Logging, we do not want that to happen. And we can almost promise you that that's not going to happen, right? That's a key focus in today's topic. Now, logs are notorious to be chatty. Their volume is humongous. And it's hard to predict how much you will need to store unless you have or you are under certain regulation. Let's say you are a gaming company and you're storing logs, right? Every single user actions get converted into a log byte, which in turns increase your log volume. Now, to support the growing need, it's essential that you use a logging solution that scales without a performance hiccup. Here at Google, we have so many different tools which supports billions of users. So we can tell you that our logging solution will not break at scale. We support structured and unstructured logs, including query languages and global search. Now, let's talk about logs. Google Cloud Logging enables you to collect both structured and unstructured logs from your data source. Also, you're able to collect logs from within GCP and outside of GCP, such as hybrid cloud or on-prem. What is important is when you collect logs from outside, meaning logs that were born on another cloud or is not cloud native at all, it is crucial to give you the same level of experience to analyze logs, regardless of where it was born, right? You kind of need the same level of experience because essentially every single company is trying to create the single pane of glass view. So here in cloud logging, you get the same flex. Once the logs are ingested into cloud logging, you essentially get the same flexibility across all log types, which gives you a greater advantage when you build a centralized logging solution. Now let's talk about structured logs. If your logs are structured and they are cloud native in GCP, that's of course a huge bonus, right? You get day zero observability because logs are collected, stored, and are available to view in context automatically. There's nothing that you would have to do to push your logs into the cloud, into Google Cloud Logging. And there are so many tools that are available out of box, like thousands of metrics are being collected for free. Certain types of audit logs are stored by default for, I believe, 400 days. And there are several out-of-box dashboards that your ops team can start running and look into key metrics and system health and understand how your platform is performing overall. And all of that is available for you out of the box, right? Now that's structured logs. But if you have unstructured logs, and in the event you want to combine your structured logs with your unstructured logs, for logs that are born outside of GCP, you can achieve a similar experience by pre-processing the logs. Like you have two options, right? One is you can choose to pre-process your logs, or you can dump them into our API and use full text indexing capability. I'll talk to you about what FTI, full text indexing capability, is in a bit more detail in the next slide. But to pre-process the logs, there are multiple options. We support open source and that allows you to use like a logging agent. Bindplane OP is a partner that we work with, and you can also use client libraries. So this transformation needs to happen on the client side. Now, once it's done, you can send the JSON payload to our API. Alternatively, like I mentioned, you can send the data directly to our API and use the full text indexing. So what this enables you to do is when you convert like an unstructured text into structured or a JSON payload, it essentially gives you the same experience as what you would get if your logs were born within GCP, right? Now, let's talk a little bit about what full text indexing is. Cloud logging was built to handle incredible scale, including all Google Cloud's debugging logs for services such as Gmail, search, ads, etc. It was originally optimized for showing fresh logs for a specific virtual machine or application. But over time, we've seen users need to search across petabytes of data that span many different resources that power their system, and often over days or even months of data. This need motivated us to develop log analytics, which leverages the power of BigQuery for fast needle and haystack searches and aggregation. So full text indexing can search across all feeds and logs up to 40 times searcher. So all you have to do is kind of use the search function in parentheses and search, right? So when you dump in an unstructured text, you can essentially make use of full text indexing to perform your log analysis. All right, now let's talk about ways to collect logs to use SQL, right? Now, there are two ways. One is a managed service way. Another one is a DIY way. Let's start off with understanding the managed service way. So the managed service way is called log analytics, and it resides in cloud logging. It's a feature. So what happens is when you send your log data to the cloud logging API, and it goes into the router. At that point, you say, okay, I want this logs, I do not want. You can use inclusion, exclusion filter. And then you say, okay, these are the logs that I really want to analyze. And then you store them into a log bucket. Once the log is in a log bucket, which is very different than your Google Cloud Storage bucket, logs are automatically indexed to optimize performance. Full text indexing is turned on by default, right? Then you enable the bucket to support log analytics. Once you enable turning on log analytics, you are now able to run a SQL query from your cloud logging, right? So what is this done? Like when you enable a log bucket, what happens in the backend? In the backend, we use BigQuery. So it supports native JSON columns, right? So native JSON support gives you a ton of flexibility as it allows you to evolve your schema over time. You can keep dumping your data without much pre-processing, and log analytics enables you to be flexible at query time with schema on read. In a schema on read scenario, different types of data, potentially structured and unstructured, are loaded into the destination. The schema is generated when queries against the data are executed. Basically, ingest any JSON data and it will still be performant because BigQuery stores this in a columnar way in the backend. A linked data set is created and it allows you to execute queries in two UIs. You can go and execute in BigQuery UI, or you can execute in the cloud logging UI. We'll show you how this works when we get to the demo part. Now, let's talk about option 2. Option 2 is the DIY, do-it-yourself method, right? Where the logs are coming into the cloud logging API, and in the log router, you're setting up a log sync to send it to BigQuery. Now, this is DIY because you have to do everything by yourself, right? You own the data in BigQuery, and it does not support the native JSON format because you will have to, again, do that by yourself. Data would be stored into several columns, and just a caution that you might run into limit issue. And then you would have to create your indexes manually because everything that is associated with storing, managing, and creating an efficient log database, you would have to do it yourself. Right. But once you figure out, if you have in-house BigQuery experts, and once you figure out how to do that, you could manage your own slots, you could manage your query optimization, and you could essentially combine the log data with any other business data in BigQuery. And that is also possible with log analytics. That's a key advantage. So the advantage of using a managed service is everything is done for you and it is super fast, and you can still use the linked data set to, excuse me, the linked data set to merge your data with any other data that's already residing in BigQuery. Excuse me. Awesome. So how different is analytics enabled bucket, logged bucket, is different than routing logs to BigQuery? We just saw the two approaches, right? So what are the key differences between those two approaches? Number one, log data in BigQuery is managed by cloud logging. So it's automatically indexed, like I mentioned. And when you store logs, the data residency and lifecycle are managed in cloud logging, which is number 1 and 3. Number 2 is kind of crucial and important if you're running large volume, right? BigQuery ingestion and storage costs are included in your logging costs, meaning you are able, there is no separate querying cost when you use log analytics within cloud logging. Log analytics and cloud logging is a fully managed service. It is built in BigQuery ecosystem, and what makes the backend powerful is truly the performance. Here, in this slide, I have a chart on the right side, right? It was published by a media company, and they were experimenting on the query performance that was run on BigQuery versus an alternative cloud. So, result of their experimentation, they found out that the query performance is about much better in BigQuery, and they found about 47% of the queries took less than 9 seconds to execute, which is pretty amazing, right? When you think about logs and them becoming very chatty and voluminous, it's truly important that you don't break the performance, like I mentioned earlier. And BigQuery being one of the stellar fast backends, it enables you to really execute and run at speed. And towards the end, when you're in the middle of a troubleshooting, that's all it matters, right? Being able to get your result pretty quickly, and you're able to get to your MTTR at much faster rate. Now, let's understand why SQL, right? Number one is SQL is a very versatile and powerful language. BigQuery search indexes lets you use Google SQL to easily find unique data elements that are buried in unstructured text and semi-structured JSON data without having to know the table schema in advance. With search indexes, BigQuery provides you a powerful columnar store and text search in one platform, enabling efficient row lookups when you need to find like an individual row of data. A common use case in log analytics is, let's say you want to find a data that's associated with one user for your GDPR purposes or GDPR reporting, right? All you need to do is execute the search function and it enables you to find it super quickly. We're also going to show you how to execute one SecOps use case towards the end of this session. With search indexes, you can reduce the need to export text data into standalone search engines and instant build a data-driven application to derive insights based on text data that is combined with your rest of the data directly in BigQuery. Now, search function enables you to comb through petabytes of data efficiently, right? Like we already talked about the full text indexing, and we also saw about how search function is really crucial to get to the speed and performance that you're looking for. Like if you want to comb through your system logs, networking logs, or application logs that's present in the backend in log analytics on the BigQuery table, you would use the search function. If you want to do a troubleshooting, if you want to perform a security audit, or if you want to just look up a pre-processed text, like let's say if it's a call center and you're just looking for one sales ID or process ID or order ID, it is super, super fast for you to use a search function and look up for that one particular log field or log information that you're looking for. Now, Sumit will now walk us through the different use cases where you will be able to efficiently use SQL and talk to us about, or actually show us how to implement it super fast. Over to you, Sumit.
Thank you, Afrina. All right, so for log analytics, whenever we're talking about use cases, we think about personas. What kind of users are trying to use our product, right? So the most popular use case is for developers and operators out there. For the DevOps use case, if you have some kind of service running in the cloud or on your on-prem, and you need to troubleshoot it, ultimately you need to look at the logs to find the root cause of the problem. So this kind of root cause troubleshooting, you need to analyze large volumes of logs to look for patterns and look for trends and see when a certain kind of problem started to happen. And for this, log analysis is great because you can scan large volumes of logs, look for patterns, certain regular expression patterns, or it could be token matches over large volumes, and then iteratively kind of refine the query. You might want to group by certain fields, break down the values, and try to visualize it to understand when something started to happen and where the root cause could be. So troubleshooting is probably the most frequent use for log analysis, and I'm sure all of you have some experience doing this. So I'll probably show you a demo of this as well, on how we can leverage log analytics for troubleshooting. If you could go to the next slide, please. So the number two use case that's popular is for IT operations, is analyzing networking logs. VPC flow logs, for example, is very voluminous. You can enable VPC flow logs in your subnet, and you can either have 100% or you can sample it down and aggregate it and only emit certain VPC flow logs. But this is really interesting because it kind of tells you single thing that's happening in your network. You can break down by the source IP and destination IP and what's being accessed, how much data is flowing through your network. And some of these fields are very high cardinality. And there are lots of dimensions, and each of those dimensions have very high cardinality data. So to analyze high cardinality data, you can use log analytics and be able to filter on a certain IP address or group by and look at the top talkers on your network. So it's a very powerful way to analyze at a very large scale and find the insights by looking at these patterns. Next slide, please. The third use case is again on security. For security operations, it's very similar, but now you are wearing the security hat and trying to look for security threats, any kind of unusual patterns. One popular example was the recent log4j vulnerability, where you need to scan for a certain pattern in your logs and see where the impact is, right? And for that, you need to scan like petabytes of log data over a long period of time. You're not only looking at the real-time data, but historically, how much has there been any threats? Has there been any kind of attacks, right? So we can leverage the power of BigQuery, the BigQuery's ability to scan huge amounts of data and find out and look into the security threats. So I'm going to take a quick demo of a few of the capabilities here. So switching to my demo here. All right, so this is the Cloud Logging UI in the GCP console in the Operations Center. So this is the normal logs explorer, where you can look at the logs line by line. There's a histogram to visualize the logs and some field breakdown. What we have introduced in the past year or so is the log analytics feature. So if you want to analyze your logs using SQL, this is great. And you can use the same SQL that you would use in BigQuery and put a SQL here. You would see your buckets that are available in your project, and each bucket has views. And once you press this query button, it gives you a default query to start out with, right? So you're basically looking for 50 sample logs in the last 1 hour. This UI is very specialized to analyze your logging data, right? So you can look at the schema of the data, what's available, what fields are available for audit log, for example. So the schema is here. And if you run this query, you're basically executing this BigQuery underneath, but this is a customized UI which makes it very easy to analyze logs. So as Afrina mentioned, some of these logs are semi-structured, meaning there's lots of JSON data in here. We make it very easy to look at JSON data and work on JSON data. For example, I want to filter on a certain cluster location. I can just use these fields and interactively kind of refine the queries as we go by. So this is a default query, right? So what are some of the interesting use cases that we talked about? So for example, I have a demo application that's running on GKE clusters in this project. And I'll look into a service, a front-end service log. So I have an example query here. Let me get the query. Give me a minute here. All right. So in this example query, let me copy it here. All right. So I'm basically looking for a pod name with starts with front end, right? So these are my logs from my front end service. So notice that I'm using the JSON value function. So these labels are stored as a JSON, native JSON type in underneath. So these JSON type can have fields that change schema over time, but you can just use the JSON value function and use the same dot notation to go into the JSON value and, like, for example, JSON payload.message and try to match certain request complete messages, right? So if I run this, I can find all the requests coming into the front-end service. So I can look at all the HTTP requests, method, path, bytes, status code. And this 2 milliseconds looks interesting because that's the latency it took for a particular operation in the front-end service. So, when you're trying to analyze logs, maybe you want to look at, extract this value and try to aggregate it out, right? So normally you would use a metric for it, but if you want to use logs and extract values and do aggregations, you can do that with SQL. So I have a query prepared for you here. So I'm gonna copy this. For this particular query, what it's doing is looking for the same front-end requests, but now I'm trying to extract the JSON value, casting as an int64, but now I'm looking at the minimum, maximum, and average of the latency. Right? So this type of aggregation is super powerful. And I'm looking at the last 1 hour. I might want to extend this. So we have this time selector menu, which makes it really easy to change time. Instead of last 1 hour, let's look at last 1 day. So I'm grouping by hour and looking at mean, max, and average of the latency. right? So this is a textual kind of like a tabular result, but if I want to visualize it, we also have charting options to look at what the maximum minimum average looks like. So what this might be helpful for you to kind of understand if there's all of a sudden a very large latency spike. And then once you see that spike, you can now use any of the fields in your log, even the high cardinality fields, to kind of filter out and find out where that latency is coming from, like which part of your microservices architecture, which service, or which application is it coming from. So it allows you to look into any detail, any of the fields in the logs using SQL. So this is super powerful, and it helps you troubleshoot logs using all the power of logs with high cardinality data, and helps you analyze and understand what's happening to your application. So let's look at a networking use case. So as a user who is kind of trying to understand what's happening in my network, I can look at the VPC flow logs. So VPC flow logs have to be enabled. It's turned off by default because it's very voluminous. But VPC flow logs are super useful if you aggregate it, because the power is on the aggregation. Because if you just look at VPC flow logs by itself, it will show you how many bytes were sent between what source IP and destination IP pairs. And it also has metadata, because this is using GKE cluster. I can look at the pod name and the service names in here as well, right? So imagine trying to aggregate this data and then grouping by all of these metadata that's available, right? So I have one example query where you can analyze this in a better way. So the power comes in the aggregation and group by functionality to understand what's happening in your network. So for example, in this particular query, I'm looking at the source flows, and I'm trying to group by the destination pod and aggregating by the total byte sent, right? Summing over the byte sent. So let's run this query over the past 1 day. So I can see how many bytes were sent by each of the destination pod, right? So if there's any abnormalities, or if you want to filter on a particular pod and again dive into what the top IP addresses are, that's also possible. And there's also quick ways to visualize this to understand it better, what the top users are. All right, so one other example I have here is looking into a more security use case, right? Just like networking, security, like every single event that's happening in GCP is logged. All the activity that's happening, you're making any API request or any kind of data accesses, all of those things are logged in cloud logging. So some of these are enabled by default. The activity logs are enabled by default, but data access logs needs to be enabled. Once you have those logs flowing in your system, you can filter on the audit logs. I'm just going to show you how the audit logs looks like first. Audit logs use proto-payload fields. So these proto-payload fields are structured, but you can still look at it in a very easy way. Which service name, which method name is being called. And you can also look at the principal email, which service account is making these accesses, and where these, what's the origin of these kind of requests, right? So you can look at the request metadata and see the caller IP, user agent, and these kind of high cardinality fields as well. So to visualize this, let's look at an example where I am doing some aggregation, and I want to find out who are the top caller IPs for a request coming from a particular principal email. So I'm going to use a query where it's filtering on a principal email. This particular service account, I want to look at the top caller IP addresses. Right? So this gives you basically the top 5 caller IP, and you can see if there's any kind of, we can look at the top end or the bottom end and look for abnormalities, what's expected, what's not expected, what IP address ranges are expected. If you want, you can also use charts to visualize this better. It's kind of categorical charts. So this way you can do very basic analysis within cloud logging using the log analytics. But if you want to do even further analysis and create dashboards and reports, you can access the same data in BigQuery. You can essentially just click this Run in BigQuery button. The way this works, as Afrina mentioned before, is it creates a linked data set in BigQuery. So you can you get a read-only view of this data. So it's very easy to access the same data from BigQuery. And once it's accessible from BigQuery, you can then use Looker Studio or Looker to kind of create more advanced visualization, or any third-party tools using the BigQuery APIs. Okay? So when you're doing this, the data stays within cloud logging, but you have the full power of BigQuery to analyze it further. Okay, so I have a couple of slides again. If we could switch back to slides.
Yes. One moment.
So one example for Looker, like the same kind of data access, we're looking at the data access audit logs, and you want to look at who the top users are by source IP and destination IP. This is a Looker block that's available to you. It's easy to visualize, much more rich visualization, and you can also have this kind of filter drop downs to select these things. There's a link to this visualization. The Looker block will make that available as well. One slide forward, please. Another example for security. If you could go to the next slide.
This one?
Yeah. One slide before this. Yes. So this is another example of using Looker to understand what's happening in your system. Right. For example, I'm looking at all the data access by service on the very top left. Looking at the data access logs, I can visualize which services are being used and who is using them, right? So by principal email, you can look at who's accessing what kind of data and also from where. You can visualize using a geolocation to kind of understand where are these requests coming from, right? So this kind of visualization makes you very easy to understand all the accesses that are happening to your data. And if there's any kind of anomaly or any kind of unexpected things, it's easy to detect them as well. All right. I think I'll hand it over to you, Afrina.
Thank you so much. Awesome. So let's quickly talk about CSE. I saw this question come up in chat too. So community security analytics is a set of foundational security analytics designed to provide organizations with a rich baseline of pre-built queries and rules that they can readily use to start analyzing the Google Cloud logs, including audit logs, VPC logs, DNS logs, or more using cloud native or third-party analytics tool. So the source code is provided as is without warranty. As organizations go through autonomic security modernization journey, this repository serves as a community-driven list of sample security analytics for auditing cloud usage and for detecting threats to your data and workloads in Google Cloud. These may assist detection engineers, threat hunters, and data governance analysts. So if you see, like if you have all the audit logs collected or data usage logs, here are the top queries that we think we have the repository built for you to help answer, right? Like say, for example, when it comes to data usage, if you want to know what tables are most frequently accessed by whom, this is oftentimes one of the top query that's run for generating reports, compliance reports, right? Then if you want to know the highest number of API usage, like which user is using, has an unusual API usage, that's easy to filter out. Any table being referenced by a new user identity. And the same thing with login and access. Who is accessing the data? Where are they accessing? Like this is also crucial. Like let's say you have some blocked IP addresses and you see that your users are accessing from them, and then you instantly know your Looker dashboard or your other visualization tool will instantly tell you that, oh, there's something wrong and you need to take action on it, right? Any access attempts violating the VPC SC laws, that again, your VPC and your logs can help you get to that. The same thing with IAM and keys admin and cloud provisioning. So all of the queries are built in our CSA repository, and the link is here on the GitHub. So if you go to our GitHub, and these queries And this repository grows over time. It's community driven. As users find more and more use cases that they're able to execute on log analytics, they continue to add. So this should be a very easy and straightforward way for you to get started today using log analytics. Now, let's see an example of a SecOps use case, right? So the power of using SQL is this, that you're able to run a complex query at one go and be done. Like, for example, in this query, you see, the first part is you're able to show who granted access to who. That's important. Over what time frame, at what service account level, or at a higher level than the resource hierarchy. And you're talking about excluding approved grantees, like who can you exclude? So when you're able to execute all of these complex conditions in one SQL query, your performance is fast, and you can then export all of this to a Looker dashboard or another for reporting and alerting purposes, or a monitoring dashboard that we are going to add in our roadmap very soon, right? So SQL gives you the power to run complex queries, and you're able to visualize that at a heartbeat. So towards the end, it's all about consolidating different tools, right? Without SQL in the previous world, people would be using the same log data, ingesting into 4 or 5 different tools to do different things, right? The same data, but then the front end UI will be different. But SQL kind of gives that it makes it very versatile, the flexibility. It allows you to run the complex things, and you don't even need so much background knowledge to get started, right? There are so many tools that's available that can help you build queries, or repositories available that you're able to leverage. And in log analytics, you're able to save, like even within our own team, that's what we do. One person writes the query and they're able to save, and then it's easy for other sister teams or parent teams or child teams to go and just click on, okay, go to a saved query and then click on it, and you're able to run the query. So the repository of saved queries can be built by your platform engineering team, and all the other teams can essentially leverage this, thereby saving a ton of time. Awesome. So, Samit, do you quickly want to talk about this particular slide about alerting and dashboarding?
Sure thing. So this basically shows you a typical architecture, how you might want to use cloud logging, BigQuery, as well as Looker. So you have your logs stored in cloud logging, and you can let cloud logging manage your logs in the best way possible and optimize it and store it in the best way possible. And we have the ability to create linked data sets, which you can use to query the same logs from BigQuery. And using the community security analytics queries, if you find some interesting queries that you want to run repeatedly, so you can use scheduled queries feature in BigQuery to run this query over and over. And if you find any kind of anomalies, you might want to alert on it. So there are a couple of ways to do such kind of alerting. So one way to do this is by leveraging event arc triggers, by publishing an event arc message, and then triggering a notification based on that. A new way to do this is we have now an ability to create a metric output from the scheduled query, so that you can use a regular alerting policy to alert on that metric. So if you want to use this feature, it's also available now. So the scheduled queries can be used to analyze certain kind of queries over and over, and then get you alerted if there's something that's happening just using SQL queries. And with the same linked data set, we can build dashboards in Looker. And we're also now going to introduce dashboarding capabilities within cloud monitoring by connecting log analytics queries and the visualization charts into a dashboard in cloud monitoring. So those are all coming in the future soon. A native ability to visualize dashboard as well as create alerts. All right, so this is again another example of looking at unusual API uses. This is if you want to find out who's accessing what kind of data, and in the last 7 days, for example, there are certain principal emails that's accessing the data for different kinds of API events, right? So you can imagine cloud logging having the heartbeat of Google Cloud. So it has all the access information, and you can build these kind of dashboards and create alerts to kind of alert you if there's any kind of unusual activities that are going on.
Amazing. Yeah, thank you so much for that presentation and for the demos. And thank you everyone for joining us and for your questions. We will get to your questions shortly. We are just going to cover a few resources first, but keep those questions coming and we'll be happy to get to them. First are just a few links here to help support you on your journey and if you run into any questions. So again, that link at the top is to the community. So if you have any questions, you're looking for answers, that's the place you want to go. You can ask questions, engage with your peers and with Googlers there to get your questions answered and also to find out about upcoming events like this one. So with that said, there's the link, that third link to upcoming events that we have. We have one just after this for learning Google Cloud for AWS and Azure professionals. And then of course, Google Cloud Next is coming up in August. So if you want to stay tuned, check out that third link there for what we have coming up. And then lastly is the feedback form. So this will take you just 30 seconds to a minute, but we'd love to hear your feedback on this session, or if you have ideas for future topics that you want us to dive into, we'd really love to hear from you, and we will drop that link into the chat shortly. All right, and with that, we're going to dive into some of your questions. So like we said, keep those questions coming into the chat, but we're actually going to start with some that we received in advance. So our first question is, I'm interested in blueprints for getting metrics from logs. For example, an efficient way to get the amount of a specific level of log messages or the distribution of errors over a given time period.
Yeah, so I think this is a very interesting question. There are multiple ways to do this. For example, the traditional way that our customers have been doing this is using log-based metrics. So with log-based metrics, you can basically match certain patterns in logs. Once you find matching patterns, the log-based metrics can essentially count the number of matching logs. But you can also add labels, custom labels to this metric by extracting some other fields out of the logs and putting them as labels, right? So this essentially creates a metric in cloud monitoring, which you can use to visualize in dashboards as well as create alerts out of it. So if you are interested in particular fields in the log message, you can just create a log-based metric. Or you can also create a distribution metric instead of a counter metric, which extracts some numeric value from the logs and creates a distribution so that you can build a heat map like chart, or you can also look at percentiles of the value to understand, for example, latency values in logs, right? So log-based metrics is one way. The other way is using log analytics. The difference here is log-based metrics operate at ingest time. As logs are ingested, we match those logs and then write to a cloud monitoring metric. Whereas if you are using SQL, you can do the same essentially by running a SQL query, matching those logs, and looking at even more powerful analysis. Let's say you want to look at high cardinality data, then you might want to use SQL for that. And with the ability to create charts and alerts out of it, you can essentially do the same thing as a log-based metric, but even for more high cardinality analysis, as well as more advanced analytics, you might want to prefer using log analytics.
Awesome. Great. All right. So our next question is, what can you suggest as a secure and efficient way to store logs outside of the GCP project to have the investigation or audit teams working on them without project access?
And that's a very interesting question because cloud logging operates by storing those logs in our own managed storage, right? So you cannot essentially have your logs outside of GCP. So you have to bring this in GCP first. So if you have either a third-party cloud or on-prem, you'll have to use some kind of either logging agent, or we partner with ObserveIQ for the bind plane agent to kind of bring these logs, right? So you can store them elsewhere, but if you need to analyze and bring it to cloud logging, you can do so to use our use our tooling to analyze them within GCP. But there's not a way to kind of access data that's outside of GCP in cloud logging.
Also, to add to that, there are special IAM permissions in Google Cloud that you could give just for your auditor, right? If you don't want your auditor to have access to every single project data, you can create an IAM role, I believe, And then you can just give them access for investigation and audit purposes, and then you can remove that access. So there are specialized roles available for you to perform this action.
Great. Okay, and then we have one from the chat here that I'm going to pull up. Any scenarios when it is recommended not to use log analytics?
That's a very interesting question. I think if you think about it, in cloud logging, the only cost you are paying is our ingestion cost. Like if you are routing those logs into log buckets and storing it in cloud logging, you pay the ingestion cost and then storage cost if you're retaining more than 30 days. The queries that you run in cloud logging, whether it's SQL or whether in the logging query language, all queries are for free, right? But if you use BigQuery and then analyze those logs in BigQuery, you still have to pay the BigQuery cost, right? But with the cloud logging, we want to make sure that you don't have to worry about the query cost. So it's for free. And the only reason I can think about where you would not want to use log analytics is if you want to mutate the data, right? Since the data is managed by logging, and we want to make sure that the logs are non-mutable. And once it's in logging, it's a kind of a record that's happened, something happened in the past. You can delete the log, but you cannot kind of muck around with the logs, right? So if you have a use case where you need to modify the logs in some ways for your application, then you might want to use BigQuery directly and own the data yourself, and then you can do whatever you want with the data.
So what about using older logs, right? We support real-time log ingestion, but would you say log analytics will also support, let's say they want to bring in 1 year worth of old log data? Would you still recommend?
Yeah, so log analytics and cloud logging is more for like, real-time streaming ingestion of logs. So if you have historical logs, there are certain ways to ingest them. You can also retain those logs for a very long time for archival purposes, and you can store them for up to 10 years. But your ingestion has certain limits. You can only ingest up to past 30 days in the past, but you can also ingest future logs up to 1 day in the future. But yeah, if you have very historical logs you want to bring in and analyze, you might want to put them in BigQuery directly as well.
Makes sense. Okay, we have just a few more. Is there a way to stream these logs to PubSub to integrate with external SIM tools?
There is. So we offer a Cloud PubSub export. So from cloud logging, you can set up syncs to export logs to Cloud PubSub. There are also exports to BigQuery as well as Google Cloud GCS. So if you want to integrate with an external SIM provider, you can use PubSub and then have a subscriber on the other side to get these logs. You do incur the PubSub cost to export the data out.
Makes sense. All right. One more here is how to set up proper alerting notifications from cloud logging and also know the exact alert in the notification.
I see. So I think what this is referring to is you want to see the actual log lines that cause the error in your alert notification. So the best way to do this is using log-based alerts. So the log-based alerts is very helpful if you want to send an alert every time a single log entry comes in matching a certain criteria, right? So when that happens, you will get the actual message that was in the log in your notification. If you're using an email, you'll get that as an email or other Slack channel or webhook notifications. You'll get those actual log lines in there. So try looking for log-based alerts. It's right there in the Logs Explorer. You can create an alert using logs.
Yeah.
Okay. How can you identify the root of the error in a very long error trace? For example, identifying keywords, which statements, examples, or codes most used.
So if I understand this question correctly, what the user is trying to understand is they have when you're trying to analyze the root cause of an error, and there were lots of logs, and I would suggest first of all filtering by severity, right? Maybe you are only interested looking at warning and above or error and above, right? And even if those are lots of logs and you want to find out patterns, Logs Explorer itself has this pattern matching feature where you can hide similar logs. Let's say you are not interested in a very large number of voluminous logs, then you can look for similar logs and hide similar logs, right? So hiding and revealing similar logs allows you to kind of comb through your log, get rid of the noise, and look at where the interesting patterns are, right? So once you get rid of the noise, then the actual root cause becomes much clearer. So I would suggest first filtering by severity, reducing the log volume, and then getting rid of other noisy logs using the hide similar logs feature.
Great. We have just 2 more questions, and I think that's all that we'll have time for. So if you do have any additional questions, please utilize the community, and we'll drop the link there into the chat. So second to last one here is, we use private Google Access and VPC peering for hybrid connectivity. How can we check the traffic is getting to GCP when troubleshooting?
This is actually quite easy. You'll have to just enable VPC flow logs in a VPC subnet. So there are also, as I said before, you can, if you want, you can do sampling of it. Just ingest a certain percentage of those VPC flow logs, and then those will tell you, as I said before, like, you know, exact VPC, like every network flows that you can analyze it. And if you just need to check whether the traffic is getting to GCP, you can enable this, analyze it, and leave it on if you want to do further analysis in the future. But if you just want to check, VPC flow logs is the best way.
Makes sense. Okay. Last one from the chat. Thank you for joining us. How are the pricing models different using log analytics and syncing to BigQuery and analyzing there?
Well, I kind of answered this before, but I'll repeat again. So in cloud logging, we have one pricing, which is the ingest pricing, 50 cents per gigabyte. We allow 50 gigabytes. First 50 gigabytes is free. So if your workload is very small, then you can get 50 gigabyte free per month, and then from then on you pay per gigabyte. Right? There's also a storage cost if you're retaining more than 30 days. There are no cost for querying the data. Right? However, if you export the data out to your own BigQuery dataset using the syncing mechanism, then you have to pay for the streaming ingest cost to BigQuery, the storage cost in BigQuery, as well as the query cost in BigQuery. So there are additional, like the normal BigQuery cost applies when you are exporting data out to your own datasets. But if you let Cloud Logging manage the data, you just have to pay ingest costs.
Great. Okay, thank you, everyone. We also dropped in a few additional resources into the chat regarding pricing and additional information about connectivity tests. So please check those out on your own time. Thank you so much again, Afrina and Sumit, for this session, for the demos, answering so many questions, and thank you everyone for joining us. We would love to see you next time, but before then, any final thoughts or closing recommendations before we wrap up today?
I want to say thank you so much, and we truly appreciate the time you've given us and the time people have taken to attend this session. If you have any questions, please send it to us via the Cloud Community group, and we'd be happy to answer. And we can also send blog posts for you to help get started. But any questions, please send them our way. Thank you so much.
Definitely. Thank you so much for joining and for the interesting questions. The team here is working very hard on kind of building new visualization and other alerting functionalities. So keep watching the space. We are launching new features soon. So stay tuned, and we'll reach out for any questions, and we'll see you again soon.
Amazing. Thank you, everyone. And we hope you have a good rest of your day or evening or wherever you are in the world. We hope to see you next time. Thank you.
Okay.